All right. Welcome everybody to the IGIS demonstration of working with drone data in ArcGIS Pro. This is a new presentation that I'll be giving today. It's part presentation, part demonstration, where one leaves off and the other starts, I don't know. But during the next close to an hour, I'll be going over the steps that I do all the time for working with multispectral data coming from a drone. Last week, I gave a companion presentation to this presentation today, going through the process of photogrammetrically processing drone data using Pix4D Mapper. And where that left off, we're going to continue today working with the Pro application. If you have any questions, please throw them in the chat. I have my colleagues here, Priyanka and Genoa, that will be fielding questions, as well as Genoa will be sending out an evaluation at the end of this, and it'd be great if you could fill that out. Without further ado, I do have a very short list of steps that we'll be going through today. Start off with a very basic introduction to ArcGIS Pro, but it doesn't sound like I need to do that so much since everybody's at a fairly solid level here. We'll create an ArcGIS Pro project, connect to folders, the standard workflow of getting going. And then I'm going to get into some data management and organization steps that are kind of specific to drone data. Specifically, when you create a project and you need to package it up in a way that you can deliver it to other people or be able to jettison your old intermediary files that you pile up like amazingly and with the photogrammetric processing that you don't ever really need later on, so you can get rid of those, but you don't want to accidentally get rid of anything essential. Well, when I'll go through the steps of how to organize data so that doesn't so you can keep your drives nice and clean. Be loading up drone data indices and layers coming from the image processing, as well as photo points and creating the points from your XY data. And then we're going to get into some geoprocessing tools, compositing bands, uh, and then also organizing your data structure with other files, going to a little bit of management again. We're going to create feature classes for clipping. We'll go to jump ahead to some symbology, working with how to mask your imagery, which is a common thing that you'll need to do. We'll go through some of your imagery tools, for example, to create an NDRE or normalized difference red edge or a hillshade. Then go into some symbology, where we'll be copying mosaics for creating both false color infrared as well as RGB imagery mosaics. And finally, we'll do some blending of the DSM with hill shades to make something that's pretty. And finally, we might throw together a quick layout. And if we have time, I can go over how to create a local scene, even though I don't do that a ton because it's really just an indulgence for fun. So that's a quick outline of what we'll be covering today. Again, if you have any questions, throw them in the chat. We can stray from some of these points or add other kind of learning elements in here if anybody has any kind of wish list of things that they would like to be able to do. To start off, I want to show, well, two things. One, a little bit about file structure, a little bit about how I'd be organizing the data in the case of like this exercise relative to, or this presentation relative to the presentation I got last week, and how file structure might be reflected in the differences there. Last week, I gave the Pix4D exercise. You can consider that to be something like if you process data within your photogrammetric processing application of choice, whether Pix4D, Open Drone Map, Drone to Map is a little bit more streamlined, but whatever, Metashape. And then you will also need to have a separate folder. In this case, for today, I've created an empty intro drone data in ArcGIS Pro folder that has nothing in it. And that's what I'll be working to. That way, after I was all done, if I ever wanted to, I could just zip that up and send that to someone. When you go through the workflow of processing your drone imagery, whatever application you're using, I'll just referring to Pix4D today, but Metashape is the other one I use. Sometimes they spit the data out in a fashion or organization that is definitely not ideal, and it has it's. I wish they would do it a little bit different sometimes, which means that you have to reorganize your data often inside of a Pix4D project. Oop, that's not it. I got to go further in. I got to go into my Pix4D projects here. If where we left off last week, this is the output that you would see from something like Pix4D. Note that if you were not working with multispectral data, you wouldn't have this index file folder. That would be something else. You'd just be working with the DSM and orthomosaic. But for today, we will be going with the most complicated output of data, which is multispectral. Well, most complicated unless you're working with hyperspectral data, which is a very rare niche. But for the kind of the more difficult or complicated type of imagery, multispectral has its own ways of handling it. You can, what you learned here with multispectral today will apply to RGB, but with far fewer steps, specifically how to composite bands and visualize that. Inside of the index folder, we would have indices. And in this case, we have blue, green, normalized difference vegetation index, near infrared, red, and red edge. So if you're not super familiar with multispectral cameras that are mounted on drones, you think of it as one camera, but it is actually usually somewhere between a 4 and a 6 separate camera instrument that are all put together into one. So in other words, when you take a picture in one place, you're actually taking, in this case with an Altum, 6 pictures or 5 multispectral band pictures where the blue, green, red, near infrared, red edge, they all snap at the same time from the same position. And then the results of those images need to be composited into one single image, like what you think of like an RGB image. As an extra output, we usually check off to create a normalized difference vegetation index because that's used a ton for any kind of vegetation health or classification interests. But I digress. Inside of here, we'll have a blue band, and in there, we'll see there's a bunch of metadata built into the names of these, by the way. So in this case, this is the Lynn Cove Research and Extension Center, Field 41 North, multispectral, and then this shows that it's just been processed through the final 3rd step of Pix4D. I've deleted them, but there's also I haven't deleted enough of them, apparently. There's also tiles that are created in that processing. I usually delete those so it isn't as much of a download to move from computer to computer. So we have all these indices. We're going to be working with those shortly. Also, if I go back a couple levels, we'll have a DSM, digital surface model. If you're not familiar with the acronym, that is the top of canopy or the top of a surface elevation model that's created from the photogrammetric processing at the same time as the orthomosaics are put together. And extras, and why it's in an extra folder down deeper. Here's the digital terrain model, which is the digital surface model, but using some form of algorithm to subtract any objects that appear to be above the ground level based upon the changes in slope. So say if you come up to an edge of a building and there's an abrupt change in slope upward, then that object will be subtracted off. And also based upon point clouds that are classified in the processing as having, say, 1 point below another point that would not be normally natural in an environment. So that is, in theory, and not always truly accurate, a surface model just at ground level. Doesn't work very good in dense canopies and in shrubs, but gives you a pretty good facsimile of actual ground level. The value of that is sometimes you can subtract that digital terrain model from your digital surface model to create what's called a canopy height model. So you can measure the heights of trees or other objects in your imagery area. Good, so that's just a little overview of the data and what we'll be looking at. Those are the 2 initial main things. Something you might want for reporting purposes later on is your report for your processing, which will give you, and why I have this stuff here, I don't know, which will give you the resolution, which you can check in your GIS, but it's just nice to have a report of what your data looks like, especially if you're going to be writing a paper and noting that some things like the RMSE error is not exact unless you're using ground control points or checkpoints. Good. Just as a little overview of where we're going to be working, what we're going to be working toward today, I already set up a project that'll be similar to what we'll be working at the end on today, or what I'll be covering by the end is this ArcGIS Pro project. And inside of here, you'll see that I'll have a 2D scene as well, which shows the imagery draped over an elevation model. We might not get to that, as I noted in the introduction, but but it is a kind of a neat visualization effect that you can do, something like this. The thing is when you're working in a Pix4D project, you can get a 3D model of something like this, but you can't drape using the elevation model or point cloud in there, because it only reflects one single band at a time. So if you were working with RGB data in, say, Pix4D or Metashape, you can see a 3D model like this in color, but with multispectral data, it'll just be your green band typically, and just black and white grayscale. Good. But when you put your data in, we'll be having a project that looks something like that, including orthomosaics in color infrared is what we're looking at here, or oops, why is that not color? I must have accidentally changed it at something. So if this was actually true color, oh, it is true color. My bad. And then that's false color infrared. That'll make more sense when we get to it. We'll also be looking at elevation and create an elevation model that looks neat like this with imagery draped over a hillshade. And one more extra step we'll be working on is how to create feature classes and clip this so you have a usable product if you need to put it in a figure in a paper or something to that effect. Good. With that said, are there any questions in the chat yet?
Nope.
All right.
But if anybody has any, feel free to put them in.
So I'm just going to close this up. We don't need to see this anymore. And I'll start going through what my typical workflow is when I create a project. And that is bringing up Pix4D. You might have to search for it in your applications, but in my case, I have it already bookmarked on the bottom of my screen. No, I have it open also. No. Come on, closing projects. Start a new project. Firing up ArcGIS Pro. Take a second. Good. And as common convention goes, I'm going to start off with a map. I don't quite follow why you would start with a local scene, because usually you have to start with map data to then create local scenes, but those are options too. But right now we'll be starting with a map. And in this case, I'm going to find a default location that's not buried deep in my drives. So remember, I created that intro drone data ArcGIS Pro on my C drive, and that's where I'm going to put this at. So I'll go to my C drive and then go to that folder that I selected before. You might have to create that folder for yourself, or a folder of whatever name that coincides with the type of work that you're doing. And then I'm going to give this some name that has a little bit of metadata worked into it. So I'll say LREC for Lynn Cove Research and Extension Center, F41 North. I could put in a date. I might not be in this case. Sometimes drone data, you do repeated flights over a given area, so you might not want to have a date in there. And so I'll just say multispectral GIS. You notice how I put underscores in here? Sometimes this matters, sometimes it doesn't. All of you that have done GIS for a while, I bet you many of you have that same sort of just natural tendency to put underscores between things just because you never know when it'll break something if you don't do that. That usually goes back to legacy GIS users like myself, but because it's more forgiving than it used to be like that. But many of you are probably chuckling saying, yes, of course I use underscores. So I'm creating a project there. And as usually things go, we need to set up a folder connection for efficiency's sake. And so as it first comes up across the top, which I won't cover the conditional window or ribbons right now, it will come up with insert in as the first option. And if not, you want to click that. And we're going to add a folder connection. Click on that. And then I'll go to my C drive and go to the Pix40 exercise folder where I've processed data before. It'll make it so I can reach into that basket data much more efficiently. Good. Now I'm going to stretch out my screen so hopefully the folks that are watching this and are watching it and recording later on can see what I'm doing. And why I have a second ArcGIS Pro project pop up, I don't know, but must have double clicked too fast or too slow. Anyway, so once the folder connection is established, I'm going to go to my catalog. There's a couple ways to do that. By default, I have options across the bottom of my screen based on the last things that I've worked on. But normally you would go to View, and Catalog pane is one of the first options right there. And under the catalog pane, which pops up on the right side of your screen, under folders, if I click that, you can see the Pix40 exercise folder now available. And you can always click these little triangles to expand upon that. Within that, I know that Pix4D is the location where I've processed data at, and I'll expand this over so you can all see. And this is a project processed through step 3. I'll go inside. This is the same locations that we just looked at, but simplified for our benefit. And we can see inside of there, the first place that I would usually go to would be my indices folder or my index folder. And inside of there, again, indices, and we have each of these different indices included here. Just because I come from a remote sensing background, and I always think of layers in terms of their wavelength from smallest to largest, as opposed to a little nuance that the Altum camera does with its production, its ordering of bands being the segments of the color spectrum or near infrared spectrum, which technically isn't color. Then they will skip from, it'll go from blue, green, red, near infrared, red edge in the order of the Altum camera in their pattern, but I usually I usually stack my data from blue, green, red, near infrared, red edge, and then near infrared. We're skipping NDVI right now because that'll be moved over here in a few moments. So with that in mind, just for efficiency's sake, I usually start with the largest wavelength being near infrared first, and I will load it in there. And there's a couple of ways. One, you can just click and hold, drag it over and drop it on your map. It'll take a minute. It might have to build pyramids to get it to come in, but you'll see it appear in your drawing order on your contents. After that, then I will go to the next one down, or the slightly smaller wavelength being red edge. Click and drag this, and I can either drop it in here or drop it on top of there, but I'll just drop it on top of it in the map window because it's a bigger target and easier to do. But if I stretch this over, you'll see then it'll be near infrared, red edge. And I'm doing this for a reason because it's just slightly more efficient in your workflow. If you do this a whole lot, you'll save yourself just, I don't know, seconds or a minute at a time eventually. But if you load it in this order, it makes it a little bit easier. Just drag and drop red, then green, and then blue. And you can see them all stack up into the window right here. The reason I put them in there like this is because the next step I'm going to do is composite bands, because we can see is that each one of them came in like this. Yeah, I didn't see any major aberrations or any kind of problems with the imagery. You can usually notice that right away. And so I'm confident that when I do a composite bands, it's going to look pretty good, even if I haven't done this same workflow with the same data set numerous times. So now we're going to jump into geoprocessing tools. I included that list of things that we were going to cover at the beginning, but we're not going to necessarily cover that in the exact order that was listed there. That was for organizational standpoint, but when you're actually doing it, usually we'll do it in steps like this, or at least I do. So just now I'm going to switch to my geoprocessing tools. I have that bookmark down on the bottom of my common panes that I use. But for many of you, you'll need to go up to your analysis tab and then click on tools to bring up your geoprocessing tools. Because I do it all, use it all the time, composite bands is my first of my favorites. But if you don't have that, then you would type in composite bands under your search. And it'll show up down there, and then click. And now by stacking them in there in order, it makes it really easy for me to just go 1, 2, 3, 4, and 5 without having to think about it. It's also nice to do this, by the way, right at the very beginning of your project, because when you have a ton of files in your contents, and then you have to spend a little teeny bit more mental bandwidth searching through and finding the layers that you need if they're not right at the top and the only things to pick from. So now we have the composite band output. So there's a couple conventions. One, you could just write it to your geodatabase, and there's nothing wrong with doing that. It just depends on how you're going to use your data later on. And in the case of some of my projects, people will want to have the imagery in, say, a TIFF format. So so they can pull it into other software applications, whether it be R Foundation or some other GIS like project thing, like, I don't know, using QGIS, whatever the case is, maybe even the old ArcMap. Some people still use that. So I sometimes will I'll create TIFFs, and it's easy for organization's sake too when you do that. So, and for now, that actually leads to what I would normally do in a project is I would go into my folders and go into the folder that's created when you create this project. And inside of that, you'll have your geo databases where it'll automatically write to, but you might want to create a new folder for imagery, for example, and put it in there. So in the output raster there, now it'd be nice if I knew what name I might use for that. Let's see if I can do this. If I can click over here and copy and paste, I can to do a little bit of typing. I'm not going to type the whole name out, but 2023 0906. And then I would typically include that whole string of metadata, LREC, F41, 41 north, and then some other information about it. For example, I know that this is MS composite. 400 feet .tif. By the way, if this is writing to a geodatabase, you can't start with a number. You can with a TIFF, but you can't with a number. So if you follow there, that I am now creating an imagery folder within that project. And you can sometimes, you can even create different layers within that imagery folder. For example, for dates, they say if this was an ongoing project that you were going to have multiple dates, so you might have a date that you put inside the imagery folder and then put this down at that level. And you sometimes might separate it out by orthomosaic, by DSM, by DTM. But for right now, we'll just keep it simple. We'll just put it in an imagery folder, just one level below the where the project was created. And then I'll set save and run. Fortunately, I have a very fast computer, so this goes pretty quick. Some computers it's going to take a while, and if even though this is a pretty small data set, it could take a long time. Good. So now we have our drone data in it, and as you can see, it's kind of a little bit bluish. I'm going to scoot this processing window over a little bit so you can see it a little bit better. It's kind of got a blue hue to it. And the reason for that is that it is not writing by default the colors of the bands, I would say correctly, but the way they really need to be. For example, this is an RGB, but the problem is the red is going with band 1. And if you remember when I did the composite bands over here, red was actually band 3 because it went blue, green, red. So if I wanted this to be a true RGB, I would right-click that and select band 3 and select the blue and make it band 1. And then we actually have a true RGB. It sometimes is a little bit off though, largely because along the outside edge below, outside of the footprint of the flight, there's going to be spectral distortion that's going to kind of mess up your the color stretch for your imagery. So the histograms of the imagery and what it thinks it like what the color should be is a little bit off. We can also adjust that a little bit if we go up to the top under raster image and play with the stretch type. So right now it's probably some kind of, this is the default. If I go standard deviation, I know from experience, it makes it nice and clean and very realistic. That standard deviation eliminates some of the spectral distortions that are throwing it off on the edges. Good. Any questions so far? Good. All right. So let's do a little bit of cleanup. What we'll do is I'll go over to the side here, click on the first one of these, go down to the bottom, Control or Shift, click, and then remove those layers. Because now we have our composite bands. It looks good. Now that those other layers are gone, you can see where those trees on the right have outside of the footprint, and I'll show you how we can find the footprint in just a second with typical processing. They have those white spots that are they're just not correct because that anything outside of the footprint is questionable usually. With this point in our project, I usually would always save. And there's not a lot of point in saving before you get to this point because, well, you'd have to start. This is the first step of anything that's been completed. Good. Well, let's put in some XY points. So in the processing of imagery, usually you'll export the XY positions of your photo points of your imagery, and that data is usually included within your Pix4D project if you do use the same workflow that I typically do. So I'm going to go in and insert that from the catalog. So at the bottom, I still have catalog option open, and inside of that, there is a photo point down at the very bottom. So alternatively, what we can do is go to our file folder here and go to your Pix4D project that you're working on, and you'll see there's a photo point. It's a text file, a CSV file, and you can either add it in from your catalog or go here, grab and drag and drop it in. Now remember that whatever coordinate system your first imagery goes into your ArcGIS Pro is in, that's going to dictate the map coordinate system. And sometimes these photo points will not correspond with that. Fortunately, ArcGIS does a really good job of recognizing that difference. But one way to check that, though, is if you go into your photo points and open that, we can look and see that it's not XYZ, it's YXZ, being this is the north south, so Y, and this is your latitude, longitude, and then your elevation above mean sea level. So that's the output. If we look at the map itself, if I right click on that, go to properties and go to coordinate system, we can see that that's actually in UTM zone 11 north based on its position. That matters a little bit because you need to conform your data usually to the coordinate system, to the imagery that you're working on, to not potentially have errors later on. But that doesn't matter too much right now. I just bring this up because that will help you to create points from the table. So what we do is we go down to this, right click on the table, go up, create points from table, and then select XY table to point, or you can do event layer. I'll just select the first one. Remember, X was actually field 3, Y was field 2, Z was field 4, and it automatically recognized the coordinate system. That's what I was talking about before. And I click OK. And you'll see, you won't be able to see very well because it's not symbolized very well. So I'll click on the dot over in the drawing order and give you a different size dot that will pop out there a little bit more. So now you can see where the photo points are at. An important next step would be to maybe clip the imagery. But before I do that, I would like to reorganize my data. So I'm going to kind of dip back into the data management and organization stuff right now. And with that, I'm going to stretch this over a little bit. Select catalog. Remember, you can also go up to view catalog pane, and that'll get you to the same spot. It'll be opened up to the same location that I was last at, which is down in the index folder. We also have NDVI in there. But if you recall what I was talking about earlier, that we want to package this up typically in one location, and that's why I created that intro drone data in ArcGIS Pro folder, is to be able to move that over there, move all of this data over to that location. So you're not split up between your project location and the convoluted file output structure of, say, Pix4D in this case. So what I do is go down to my NDVI layer. I'm not going to pull it in right from here because I don't want to have my parent project, my APRX or my ArcGIS Pro project level folder or file trying to point to this in another folder, because if I ever want to move that data over, it's a pain to try to then have to relocate then. So you might as well do it from the beginning. So what I'll do is go to my NDVI layer, right click on this, and then copy it. And now I will go back up to my folders, and I'm going to create a new folder connection. Actually, I don't even need to do this because it's here. I'm going to disregard that. That's what I might do sometimes, but we already have a folder for that. So we're working out of this. Sometimes you'll do accompanying folders adjacent to your project folder in the same folder under the intro ArcGIS Pro. That's what I was going to connect to. But for now, we can just work off the LREC 41 MSGIS that we created at the beginning. I'm going to go into imagery, right click, and into paste that here. So then my NDVI is in there, and it might not be in the naming convention that I want. For now, I might just get rid of Pix4D, and that's just Pix4D's method of naming it, kind of, and not ideally. So I'm going to delete a little bit of this and then enter. And then I can drag and drop this into my project. Oops, if it'll go in. Drag and drop. And put it in underneath my layer. So everything is going to be within this file structure. Again, I'm going to go down and get the digital surface and digital elevation model from the DSM folder. So now I'm scrolling back down to my Pix4D exercise file structure. Go into the DSM orthomosaic, expand the DSM, copy that similarly, copy, and move it up to my imagery folder and paste it there. And then similarly, adjust the naming convention just a little bit by slowly clicking it, not being impatient and clicking too fast and then having to do it again. And then enter, and I can drag and drop that in as well. And then finally, one more, I'll go down to my extras and my DTM. Copy that, bring that up and put it in my imagery folder. Why the heck's my GSM not there anymore? Oh, I accidentally drug it down there when I was moving. Good, and then I'll just adjust that DTM's name a little bit. No, we don't need that. Enter. I can add that last one in there. Good. Now, one last thing, if you recall, we still have these points that are included in there. They're coming from the table that are in the Pix4D exercise folder from that text file, but they're not in permanent memory. So what I'll do is right click on the points at the top, the photo points, right click it, data, export features, and then I'll navigate to my folders, the project folder, and then I might add another folder for vectors. Remember, I have an imagery folder and then I have a vectors folder. You could also say photo points. Go inside of that folder and then give maybe enough information to identify what you're working with, the 2023-0906 LREC F41 North photo points. And then .shp to make that a shape file. You can also write it to your geodatabase, which is nothing wrong with that either. And click OK. And then we can get rid of the other one. So now what we have now is all of our data is organized and stacked up all within underneath your project folder level. Again, if we ever wanted to zip this up and put it on Google Drive for cold storage to send to someone else, whatever the case is, it's nice and set up right now. So let's get on to a couple of other nifty steps that we have here that are very, very common with drone data. And the first of those is clipping. But to clip, you're going to need to have some kind of file, a polygon, to be able to clip your imagery. So what I'll need to do first is create a feature class to do so. And so I'm going to go back to my geoprocessing tools. And the way I might do that, if it wasn't bookmarked at the bottom, is click on analysis at the top and tools. And you can see that's one of my favorites as well, create feature class, but I can also just type in create, and create feature class will be coming up pretty soon. Create. There it is. There it is. Create feature class. I'm going to let it just make this put this inside of my geodatabase. That's fine. And what I'll give it a new name, something like map area. It could be anything. You can say map area mask, ROI for region of interest, whatever the case is. Polygon, you'll go with polygon on this one. Coordinate system. Important, make this the current map, which is the first file that came in, which is your drone imagery, because you'll want this to match up to whatever you're going to be clipping, and everything we're going to be clipping is going to be the drone imagery, which will all be in that UTM zone north, 11 north. Good. You can also look at a couple other things. One in the environment, you can do output coordinate system, but that's redundant because it's already checked. And then look at everything else down here. And there's no option for parallel processing, which sometimes you can type in 100 and that will use 100% of your computer's ability to process it. It's not that important when just creating a feature class. It's just a small, teeny process. With that, I'm going to run it. And it'll create that empty feature class, much like a shapefile. And it is a shapefile, but if it wasn't going into your geo database. So your map area, it has this polygon color symbology. Well, let's change that right now because it's a little bit easier to edit when you're not blanking over the area you want. And so to do that, we can do it two ways. We can either highlight this here and click feature layer up here and select symbology, or we can just click on the icon. For now, we'll just click on the symbology tab at the top, or you can click on the box and then click on the symbol over on the left. I'm going to click on the black outline, go to properties, and set the properties to something that's going to stand out on the map, something bold like yellow, for example, and click apply. And you'll see then that's reflected over in my drawing order as well. The reason for that is now we're going to create a polygon for our clipping area. And I'll do that is I will go up to edit with this highlighted, by the way, on the side. Edit is on the top of the tabs, and then click create. We'll have to go over to the right and click on the map area to create a polygon. And we can do a couple of these. You can do a polygon just clicking around the corners for vertices, or you can do a rectangle. For right now, I'll just do polygon. And I'm going to click on the corner dots of each of these. So 1, 2. Oh, I got to zoom out and zoom back. Click. And the reason why I'm clicking on the corners again is because, on the last one, I'll double click to close the polygon, because that area underneath that footprint in theory is going to be the best quality, and for a number of reasons, but you just don't get this distortion or these aberrations along the outside that you see here. And we also sometimes might want to go a little further out beyond that just for cartographic effect, but for now we'll just go with that, that's going to be our area. If you did the polygon option, you might create a cleaner outline. I'm not worried about that right now. That'll be up to your kind of choice if you want to do that in your own projects to outline it. But once we have that outline, we'll click save in the top left-hand corner, and then we can clear our polygon selection. So now we actually have that for clipping. Back to the geoprocessing tools. I'll click on analysis. I'll go to tools and clip raster. You can see that's also in my favorites. Instead of searching for it, I would type in clip raster, but for right now, I'll just click it here for efficiency's sake. I'll do the input raster is our composite. Our output extent is the map area polygon that we just created. We're going to click the first one, use input features for clipping geometry. Optionally, you can click on the maintain clipping extent. That's not critical. Note that no value data is going to be negative 10,000 by default. Sometimes, not always, but sometimes you might want to make that 0. But once that's all done, then we will click run. Well, actually, we want to make sure that we have a file name that makes sense. We can use the default file name right now, but we can, usually you might put this in another location like your, actually, here, let me click off of that. I might copy this, Control C, go to my folders and put this in my imagery folder. So it's there with everything else, like the last one, but clip, and then click save, and then run. It'll take a second. It won't take that long though. Sometimes on a very large clip though, this can take quite a while. We'll see once it's done. Then you have that incorrect color band order that we have, but you can see that area is now all that's of it, all that is clip. I might change back to the correct 3, 2, 1 color scheme. And remember, the symbology stretch, standard deviations look better. And now I can turn off this other one. But behind that, you see some other layers. In this case, it's the NDVI, the digital terrain model. And I don't see I must have not dropped the digital surface model in there. I'll do that in a second. Actually, I'll do that right now. We'll go to my catalog, imagery, digital surface model. That should be in here. There we go. So we'll be working with that in a moment. Good. The nice thing about this clip is then you see that there's no extra stuff around the outside of it. Just for reference, just so you can see the difference between this and conventional imagery that comes in the background, we can switch our background, our map, base map, to something like hybrid imagery, something that's very Google Earth-esque. And we can zoom in on this, make sure that I'm selecting the layer that I'm on. Where am I at? This composite right here. I have to click on this to do the next step. And I can do a swipe. So what I did is click the raster layer, selected it here, raster layer, swipe. And now you can see the difference between this and the fairly decent quality Google Earth imagery or Google Earth-esque imagery. I don't know what it is. It might be Digital Globe or Conos, whatever they're using here, but you can see that it's not bad. In some, depending on the place and time, the imagery, that background imagery can be much coarser. But even at this level, you can see that it's not as clear. You don't see like the defined features, because if we zoom in on this is a really high resolution imagery. And the nice thing about drone imagery, of course, we can surmise that it's collected specifically at times when we want that imagery collected. Say if you're trying to catch a phenologic stage of a plant, for example. Good. So there we have that. I'm going to switch back the base layer to something else so it's not distracting. So I'm going to go back to map and base map and something like the standard topographic again. Good. So a couple little things. You can do this, by the way, and just for time's sake, I'm not going to do that with the elevation model so much, but I will show you a kind of a nifty little elevation model visualization effect. And that is if I turn off the RGB and I turn on the DSM, you can see that layer there. What we can do is create a hill shade from that very easily now. And the way that's done efficiently is to go up to imagery. Once that's highlighted, go up to imagery at the top, not the raster layer, but imagery itself, the tab, and then go to raster functions. And inside of this, we can type in hill and it'll give us a hill shade option right away. I kind of like multi-directional and no scaling, and then just create it. Oops. Oh, I forgot to do something. This was simple. I forgot to add in the DSM. Now it'll work. So now you have this nice nifty hillshade. But to even make it better than that, let's play with a little bit of symbology. And inside, what I would do is I would take that hillshade and put it underneath my DSM. Put it down below the DSM. The DSM's on top, and change the symbology of the DSM. That grayscale just doesn't do it for me. And there's actually, if you click on this color ramp here and then go over to the color scheme, so clicking it on the box under in the contents, and then go to the color scheme and do the drop down, not far down there, you'll get one that's called elevation 1. And I can click that. That gives you a little bit more of a neat effect, but it's too blurred for the most, I know, aesthetically pleasing effect. So what I can do then, once this is selected, go up to my raster layer, go over to layer blend, is the second one down, kind of over to the left. And instead of normal, click on that, and darkening modes multiply, and see how it makes pop using that hillshade that's right underneath it. Since these two you want them to be treated together whenever you turn on and off those layers. Just a little suggestion, you can do control, click the first one, control, click the next one, right click, and then group, and then call that elevation. And so then that's in a group. That way you can just turn on and off elevation if you want that layer combination to turn on and off. Good. So now it looks like we're coming to the end of the hour. Wow, I was ambitious. Like I mentioned at the beginning, I have this aspiration of going through all kinds of things that I've learned over many years condensed into just an hour session. The nice thing though is I think that I covered all of the main steps that you might need for working with drone data: the composite bands, the bringing in the photo points, the creating a feature class, clip raster, selecting the clipping extent specifically so you can have something that looks like this in the end. One last thing that I might show you, just as a little kind of fun tip before we close, is copying your files and then re-representing them in other ways. I can right click on this and say copy, and then go up to the top of my map image, right click on that and paste. So then I have a second one of the same thing in there. It's working off the same underlying data, but in this case, I might want to make it a false color infrared. I'm going to turn off my elevation so that's not distracting. To do that, I would switch my band layer order, because if you recall, there's 5 bands, and it's from blue, green, red, red edge, near infrared. A false color infrared image starts with red is the near infrared. The green band is actually the red, which is the third band, and then the blue band is green. So then we get a false color infrared imagery that highlights vegetation or healthy vegetation. And apparently there's algae in that pond, that settling pond, that you don't see so much in the RGB imagery. So now if I click this off, you can see how vegetation is highlighted in a very big way. And with that, I think we're to the end of the hour. Remember, we will be putting this out on YouTube in about a week. We'll be receiving a survey sent out by Genoa Stars here very shortly.
I'm going to post the link in the chat, but you'll also get it via email.
Perfect. And also, IGIS has office hours on Monday and Tuesday afternoons that you can sign up via our IGIS webpage. You just have to Google UCANR-IGIS and you can find your way there. And yeah, if you have any questions, sign up and we'll help you out. We'd love to try and help keep this this type of work going. I'm always looking for new colleagues on stuff too. If you have any questions, well, we can unmute and talk in a minute, or we can continue to chat for a few minutes. But otherwise, everyone, please have a fantastic weekend, and we hope to see you again. Thank you.